All right, here we go. Picking up where we left off. A 4.1. Simplifying monomials and monomial expressions using the laws of exponents. Okay, those laws are adding like terms. They have to have the same base, same exponents. When you add and subtract, leave that part alone. Just add and subtract the numbers up front. When you multiply the variables or the common bases, you add the exponents. When you divide, you subtract the exponents, top minus the bottom. And when you raise them to a power, when you take an exponent, raise it to a power, you multiply the exponents. Okay, and that's what we have here in the first one. Okay, this 3 is going to multiply by every exponent, and that will give us our answer. So let's take a look at how we're going to do that. Okay, we'll start up here. We've got 2 x to the 4th, y to the 3rd, z squared, and all of that is to the 3rd power. Let's not forget there's a 1 right here. Okay, we just don't show it. Okay, so we're going to multiply that 3 by every exponent because we're taking exponents and raising them to a power. So when we do that, we're going to get 1 times 3, that's 2 to the 3rd power. That's going to be x to the 12th power, 4 times 3. Y, 3 times 3 is 9. And z, 2 times 3 is 6. 2 times 2 times 2 gives us 8. X to the 12th, y to the 9th, z to the 6th. And the question is, which is the equivalent expression? So which one has 8, x12, y9, z6? And there we go right there. It's answer D. Okay? Move right along. Problem 2. We're taking the fraction 3/4 and we're raising it to the negative 3rd power. The other thing that I didn't mention in the first one is, what do you do with a negative exponent? You flip the thing, okay? And what I mean is this. We've got 3/4 to the negative 3rd power. Following the same rules up here, the exponents are 1 and 1. You multiply the exponents. You're going to get 3 to the negative 3rd, 1 times the negative 3. 1 times negative 3 gives us the negative 3 exponent here. You flip. If you've got we don't want negative exponents in our final answer. So if you've got a negative exponent on the top, you bring it to the bottom and make it a positive exponent. If you got one on the bottom, you bring it to the top, to the numerator, and you make it a positive exponent. Okay? And then 4 times 4 is 16, times 4 is 64, and 3 times 3 is 9, times 3 is 27. 64 over 27, boom, right there, B. Okay? Problem 3. Carlos simplified the expression shown, x to the 5th, y to the negative 7th, times x to the 6th, y squared. His final answer was ymn. If he simplified it correctly, what's the value of n, the exponent on y? Okay, well, let's come back down here. So we've got x to the 5th, y to the negative 7th, and that's being multiplied by, because they're right next to each other in parentheses, x to the 6th, y squared. Okay, so when you're multiplying, order doesn't matter. I'm going to multiply the x's with the x's, the y's with the y's, and I'm going to add the exponents when I do it. So 5 plus 6 is 11, because that's the rule. Negative 7 plus 2 is y to the negative 5th. We don't like negative exponents. It's in the numerator up top. We're going to kick it down below. The final answer would look like this. Now, the x to the m, y to the n look like this form. So in this case, for our answer, and I did this so you can see what it would look like final, but for what they wanted, they left it in this form, x, m, y, n. So your n is negative 5. Okay? So when you come over here, it's either negative 5 or negative 5. Put it at either end, but don't put it in the middle. Okay? Moving on to 4-2. Okay? 4-2 is add, subtract, multiply polynomials. What I kind of already mentioned here. So if y is this and z is this, what is y, z? Remember, they're next to each other, so it means we're going to multiply these two. Okay? go down here. Let's erase all of this good stuff. Well, okay, we've got 3x plus 5. And all we're going to do here is a big distributive property. Because y, z next to each other means to multiply. So I'm going to multiply the 3x by everything here. And I'm going to multiply the 5. Distribute it that way. Okay? So here we go. 3x times x squared. Add the exponents on the x. 1 plus 2. We're going to get 3x cubed. 3x times 2x. That's plus 6x squared. Add the exponents on the x is 1 plus 1. And then 3x times a minus 5 is a minus 15x. And we're going to take the 5 times the x squared, so that's positive 5x squared, plus 10x. And 5 times negative 5 would be a minus 25. Combine like terms, put it in standard form, so you're starting with the biggest exponent first. So I got that taken care of. X squareds would go next. 6 plus 5 is 11x squared. The x's go next. Minus 15 plus 10, that's minus 5x, minus the 25. And I put my little marks under each of these so I knew I accounted for every term up there. So 3x squared plus 11x, or 3x cubed plus 11x squared minus 5x minus 25. Let's find that over here. 3x squared, 11x plus 5x minus 25 is right there. It's A. All right. Oh, that's a minus 5x. I'm sorry. It's D. It's right here. Okay. Minus 5x. Move right along. Which expression is equivalent to this? We're just going to combine like terms here. Okay. You've got, it's pretty much what I just did to finish this problem. Your issue is going to be the minus sign right here. We have to distribute this out. Okay. So let me show you what that's going to look like. Let's erase this here. Okay, we're going to start off here. I'm going to write this down without the parentheses, because in the first two it doesn't matter because there's a plus sign in between the parentheses. So everything will stay the same there. You just drop the parentheses in this case. But this minus in front of the parentheses at the end is going to change the sign on everything. That becomes a minus x squared, a plus 7x, and a minus 2. It's like taking negative 1 times each of these, so you just change the sign. Now combine like terms like we just did. Standard form, so I start with the biggest exponent. So I've got 4x squared plus 7x squared minus an x squared. That's 11 minus 1, that's 10x squares. My x's, I got minus 3 plus 7, that's plus 4x. And then I'm left with 9 minus 11, that's negative 2. Minus 2 more is minus 4. So I'm in standard form. And going back, 10x squared plus 4x minus 4, boom, there it is right there, A. Okay? Just be careful of that minus. You got to distribute it all the way across. 3. A diagram shows a rectangular garden with a 2-foot wide sidewalk on 3 sides. The length of the garden is 3 times the width. If the garden's width is x feet, what expression represents the area in square feet of the sidewalk? Rectangle, area, length times width. Okay, but they want the area of the sidewalk. So you've got some options here. You can find the area of the whole thing and subtract the area of the shaded region, and that leaves you with the sidewalk. Or you can make 3 big rectangles here and add up the areas length times width on all of them. I'm going to take the area of the whole thing and then subtract this little area. Alright, so let's go over here. Let's erase this again. I don't know. So here we go. So the area of the whole thing, when you look at this whole big area, Now this area right here is x times 3x, because it's 3x right here, it's x right here. Let me kind of highlight this a little bit. We've got the x and the 3x. So this area right here, I'll say it's in blue right here. It's 3x squared. Okay. Now the area of the whole thing, we've got 2 added to here, 2 added to here. So this whole length right here is going to be 3x plus 4. And we've added 2 from here to here, so this is x plus 2 here. So area here is length times width. So we're going to get x plus 2 times 3x plus 4. And we're going to FOIL it. We've got a binomial times a binomial. We're going to FOIL. We're going to multiply here and here. Remember, it's just a distributive property twice. So the area here is going to be 3x squared. X times the 4, that's plus 4x. Plus 6x. And lastly, plus 8. Combine like terms in the middle. 3x squared plus 10x plus 8. Now if I subtract this area right here, subtract the 3x squared, what's left over is this region right here, the sidewalk. Okay? So 3x squared minus 3x squared, that cancels out, so I'm left with 10x plus 8. Okay? 10x plus 8. And 10x plus 8, boom, C right there. Okay. 4. Given the dimensions, what would the perimeter of the figure shown? Perimeter, it's not the area of the thing, it's the distance or the length around the sides. It's the sum of all of these sides. Okay? So let's take a look over here. Again, we're going to erase this. Come back up here. So this is x, this is y. This length right here, if this whole thing is x plus 2y, there's x, this must be 2y because that and that have to be the same. So this length right here is 2y because of this. There's my x and there's my 2y. This is x here, and we've got x plus y here. And you can see that. That's x right there, and there's your y, so that adds up x plus y. Perimeter, add it all up. I'll start with the x's. I've got x plus x plus x plus x, so I have 4 x's. Y's, I have 1, 2, 3, 4, 5, 6. So 6x, or 4x plus 6y. 4x plus 6y, boom, there you go, C. Okay? Just add up your x's. We just had to find that length right there. They didn't give it to you. And that was x, so that must be 2y. Simplify. Again, we got a minus here in between. Okay, so we got to make sure we distribute and change the sign on these 3 here. So I'm going to come back over here. So we've got 3y cubed plus 2y minus 11, and I'm going to drop the parentheses because I'm going to carry this sign out. Negative times the negative makes that a positive y cubed. Negative times the negative makes that a plus 6y, and the negative times the 8 makes that a minus 8. Y cubed, 3 plus 1, that's 4y cubes. 2y and 6y makes it 8y. Negative 11 minus 8 is minus 19. Okay, 4y cubed plus 8y minus 19. It's right here, D. Okay, there it is right there. Problem 6. When looking for a new pool, the Robertsons were deciding between a traditional pool or a lap pool. Both pools were close to the same area and square footage with the given dimensions. What's the difference in square feet of the 2 pools? So you're just going to find the area here. the area here, and we're going to subtract and find out what the difference is. Difference means to subtract. Okay, so with that in mind, let's get rid of this. So the area of the first pool is 12x plus 9, length times the width of 2x. That's equal to, we're just going to distribute to both, 24x plus 18x. I'm sorry, that's squared. The second pool, 4x plus 1 times 6x plus 3. So we're going to FOIL this. Boom, boom. That's 24x squared. We're going to get plus 12x plus 6x. That's 18x. And then we get plus 3. So you notice here, if we were to subtract, this cancels out here. This cancels out here. What's the difference? 3. This pool right here is 3 feet bigger. So when we come back over here, put your 3 either here or put your 3 here. Okay, but that's the difference in the two pools. Okay, hopefully this is helping you guys out. Keep watching this stuff. Whatever you don't figure out, you'll get it over time. You can bring it into here if you ask more questions. We're doing worksheets in class. Hopefully this is helping you. And we'll pick up with 4.3 when we come back.